Hello, everyone. Good morning or good afternoon. Before we start, can you please give us a short chat or a message that the audio and the video both are coming well? All right. So seems like everything is working. Thank you for that. So hello, welcome again. And thank you for joining us today. My name is Bishoy Gerges, and I'm here with my colleague, Yoni Salo from the mobile mapping support team. And we would like to present to you today in our mobile mapping webinar series, a new episode about frequently asked questions and some of the solutions that might help you to increase your productivity using the mobile mapping systems. So let's get started. The first thing I'll just want to go through is the agenda for today's webinar. So first, we will learn about what's new in TBC 540 in the mobile mapping module. And next, we will also learn about what's new in PostSpec 8.6. So there have been some improvements on the processing of the data. And then we're going to go through some of the frequently asked questions that we receive in support regarding the GAMS operations and the DMI lever arms. So we received so many questions on how to use them, why, and how we can calibrate lever arms and so on. We will address those questions. And then we're going to go through also some of the tips and tricks to help you with post-back processing, some of the questions that we receive, some of the most problematic scenarios we see in data processing that users actually don't consider. So I want to grab your attention to that and gives you some best practices as well. And finally, we wrap up with questions and answers session and show you some resources, how you can find help. And that will be it. So yeah, without further ado, let's get started with the first topic about what's new in TBC 540. And I will leave the word to my colleague Yoni to lead the way.
Yeah, thanks, Pisho, and hello from my side as well. I hope my audio is also clear. So yeah, let's start with what's new in TBC 5.40 mobile mapping. This version of TBC was released in December 2020, so already a couple months ago, but it's still a good time to check what's new in there for MX9 mobile mapping users. So first, and maybe the biggest thing about TBC 5.40 is the registration enhancements we have done. More precisely, there's a new concept of editing the registration instead of doing like a registration top of another registration and so on. So this new feature we have implemented lets you improve the trajectory of the registered run by editing the first registration as often as required. So what this means is that you can edit the existing registration by many different things. So first of all, you can call back targets or control points you have already picked before. So imagine a case where you picked 100 of control points for a very long highway mapping run, and then you actually want to change something in the registration. Before, you would have to pick all of the targets again, but now we can actually call back the targets we have previously picked. When we have called these targets back, we can do many things. We can re-pick a target. So maybe there was a bad picking. You selected maybe a wrong corner of a road marking or something. So you could re-pick that one. You can add a new ground control point. So maybe your survey crew sends you an email the day after you already did the registration that, by the way, there were missing control points from the list we sent previously. So now you could just add those. You can remove the GCP completely if maybe it's a bad quality or something like this. You can modify the registration method used. So you know that we have 3 different types of registration computation: global, local, and combination of those. So you can swap between. And finally, you can also change the individual settings related to one GCP. For example, I mean that you can later change if the control point is used only for horizontal correction or vertical correction of the data. All right, but I think this is a topic which is better to show with hands-on on TBC. So let me switch to my software. I have it open here. This is a small run from Colorado. I have picked here 3 control points. I don't know how well you can see those, but they are here in the beginning, here in the curve, and here in the middle. And now let's imagine a case that my survey crew is telling me that, by the way, there was a 4th point in the end here, and I want to add this point to the registration. The picking I have already done here for these points. So I have done everything already. I can show you under run 1. I have the registered trajectory. I've updated the scans for this trajectory as well. So I'm pretty much kind of done already, but I now want to add this 4th point for the calculation. So what I can do, I can choose select the run, and I can select the register run tool, which we already used for this run. And when I click that one, the normal window on the right side opens. And first thing you should pay attention to is that these 3 points are already picked. This target is picked, and you see the residuals, you see the picked coordinate. So that's the calling back functionality of this tool now. So, okay, I will now do a new registration. So, for example, I just give it a name, registration to add ID 4. So I just write to myself that I added the control point with ID 4 to this registration. So I can choose select the point from the list. I have imported it already. Press plus here, and it will appear in the end of the already picked targets. Then I can just pick this control point. I will do it from the 3D view. Click there, and the point cloud smart picking window will appear here. I can use any of the techniques we have available. I will just quickly use one of those to show you quickly how it looks. I click somewhere here in the middle of the checkerboard, and then I just click the center of the checkerboard here. Of course, there are many different techniques how you can pick here, but I will just use the simple one for the sake of time here. All right, the number 4 is now picked. You see now some residuals for those. Now what I could, for example, do as well is that I could check the residuals, and I see that for point 3 and 4, the height or the elevation residual is quite big. And maybe I give a call to my survey crew, and they say, yeah, it's we had a wrong pole height, or we had a problem with something, and the height is not very reliable for these points. So I could actually select that I will use only XY for these points. And then I can choose compute, new registration, apply it. And after applying, we get a new trajectory, and then we can update the scans based on that new trajectory. So it's a really enhancement which will save you from a lot of trouble if you want to do changes in the registration. I will leave this for that. So that's enough about the registration enhancements. Of course, if you have any questions, feel free to send us a question with the tool on the GoToWebinar. We'll take them in the end. And let me go back to the slides for now. The next enhancement in TBC I want to talk about is the image quality enhancements we have implemented. This is concerning quality of left and right planar image cameras we have in the MX9. What has been changed is that we have now implemented kind of an image equalization process in the background to process better the images which have been captured in very, for example, dark environment or overexposed environment. So maybe the sun was shining directly to the camera, and then the exposure of the camera was not really a good one for the image. I have here an example. On the left side, you see a image from a kind of, I think it's an underpass, and you see the wall there, and you can see it's a bit dark on the wall, and the sky is maybe a little bit overexposed, so you don't really see any details about that wall. What we can do now, we can go to options, general mobile mapping, and there's a new box here, image, automatic enhancement of side views. So you can toggle that on, and then if you open the same image, you will see something like this. And as you can see, there's much more detail in that image. You could better maybe evaluate the quality or the condition of that wall or whatever you want to do from the images. Also, this enhanced image is exported to the next step if you want to go to, for example, TMX or Topodot with this image. All right, that's a nice enhancement we have. And the final thing, maybe a little bit minor thing compared to those two, is that we now automatically show the run locations after you import MX9 mission to TBC. So you see these colorized run locations automatically. You can also hover over the trajectory, and TBC will show this small yellow box, which will say that this is run 2 from mission, blah, 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 and so on. So that's a minor but nice improvement. All right, that's about TBC. Next, let's go to Postback version 8.6. There's some new nice things there as well. This version was released in January 21, so roughly 1.5 months ago. And yeah, the biggest thing here is improved performance for MX9 users with AP60 positioning system. So with MX9, we have two options. We have AP40 and AP60. So this is more for those who have AP60 system. So what has changed in the background is the weighting between GNSS and IMU observations. And this weighting has been now optimized in order to take advantage of more and more satellites we can now track. For example, now we can easily track up to 30 satellites, even more, because we have, like we have always had GPS and Clonus, but now we also have the European system Galileo and Chinese system Beidou, for example. So this whole computation in the background has been tweaked to work better now. And in simple way, the users of AP60 system will benefit from improved overall positioning accuracy. I have another slide where I took kind of selection of interesting improvements, because of course in the release notes there's a 1-page long list of all changes, very minor ones, some of them. So I just wanted to select some of the most interesting ones for Trimble mobile mapping users. So the first thing is that we have now a dual locking code support that's related to the licensing of the software. Before, Postback was quite sensitive on the changes in the computer and the network, and the locking code might change, and then you have a problem using your license. Now we have 2 locking codes, so Postback will tolerate better the changes in the computer and network environment. The second small thing, now you can use base station data, for example, in .crx format. So it's a compact Rhinex format that's now supported. Then there's a couple things which are affecting the automatic download processes Postback does when you import data. If you are still using, for example, Postback 8.5 or 8.4, you might see that some of the data Postback automatically downloads is not downloaded anymore properly. For example, the precise ephemeris data. This is because the provider of this data had made some changes in the file transfer system, and Postback has now been adjusted to those changes. So you can now automatically easily download the data without any workarounds. All right, that's about postback. Now we go to the part where we cover some of the frequently asked questions. And yeah, we were thinking about what kind of questions we get many times, and which are those kind of questions we could cover here in a webinar. And we identified that one of the questions is about GANs and DMI, so the optional additional navigation sensors, and especially the lever arms of these sensors. So let's see what we can tell about those. First of all, I want to give you a reminder what GANs and DMI are. So let's start with GANs. That's short for GNSS Azimuth Measurement System. So what it is basically a secondary sensor giving us heading information, so heading of the vehicle and the mobile mapping system. If you look at the left side, there's a primary GNSS antenna here in the top of the camera of the MX-9, so black antenna here, and the GANs antenna is the secondary antenna here in front of the car in this image. So this small antenna here. So that's GANs antenna. Why would you use GANs and what are the advantages? So first of all, you get faster heading initialization. So the system can faster figure out the precise heading of the system. This means that you don't need to do any special driving maneuvers. Previously, it was sometimes necessary to do like a figure-8 loop, drive very fast, brake very fast, do some turns to get the heading initialized. So GANs will help with this in the field. By this faster initialization, you can of course reduce your mission time, a couple minutes from the beginning and the end at least. And also during your mission, you will get, the system will faster recover from a loss of GNSS. For example, if you go under a tunnel or under a tree canopy or something like this. So it will also help during the mission. There are some cases when we would recommend to use GANs. First of all, we usually recommend to use GANs with low performance IMUs. This is mostly considering MX7 and MX2 with AP15 and AP20 POS systems, but also some other cases when you need a quick initialization, so also with MX9. When you are frequently stopping and you don't have a DMI, in that case, using GANs would be fine. Always best to use everything. And when you have an application where you need to drive very slowly or with few dynamics. Example of this kind of mission would be, for example, railway mapping, because the train is, the accelerations and the turns are very smooth and slow, so the IMU doesn't get too much dynamics and it might start to drift. In these cases, the GANs will benefit you. So these things were about GANs in the real time in the field. But if we think of the post-processing part of the mobile mapping workflow, you might ask if there's a case where you use GANs in the field, but not in the post-processing. And actually, there is a case where you would not do this. And we have defined this so that when there are two conditions which are met, which are that you are using a high-end IMU, AP50, AP60 would mean MX8 or MX9 with the high-end systems, and if you have a mission in poor GNSS conditions. The word poor is here a bit difficult. There's no strict line here. I would say that many typical MX9 or any mobile mapping missions are in somewhat poor GNSS conditions, because we are collecting data in the cities, under trees, under bridges, under tunnels, and so on. So when you have this kind of case, you should compare if you want to use GUMS or not. There's no really definite answer to this question. It's really case by case. So I would always a little bit think about it if I want to use GUMS or not. Maybe first disable it. If you think that the solution could be somehow better, you could enable it and see if it looks better. All right. Then quickly about the DMI before we go to the lever arms. DMI is a distance measurement instrument or indicator. It's a device you see on the left side. It's attached to the rear wheel of the car. So it's measuring the rotation of the wheel, giving us accurate distance and accurate velocity. When would you use DMI? Generally, we would say that it's always good to use it. It's never a bad thing to use it, but especially with a couple of different scenarios. So when you are in poor GNS environments, for example, again, cities, tunnels, and so on. Or if you're in an area where you have to frequently stop, or you have to stop for a long time, for example, just red lights in the city center or something like this. So what the DMI does, it stabilizes the IMU drift while you're standing still in real time, also in the post-processing. And in the post-processing specifically, it provides this so-called ZUPT update, zero velocity update information. So it tells us in the post-processing when the device is actually standing still or not. Okay, lever arms, what they are. Lever arms are the displacement vectors from the system's reference pin to GUMS or DMI, so either of those. These vectors have to be given in defined XYZ coordinate system, which is specific for the Trimble mobile mapping systems. So you have to think about what are the axes and what are the positive and negative directions of this axis. Lever arms, they have to be properly defined so that these additional sensors like GUMS and DMI have a positive effect on the data. So if we just install GUMS or DMI and we don't really care about the lever arms, it might be that we're actually getting worse solution than without them. So we really need to pay attention to this fact. Also, when we talk about DMI, in addition to the lever arms, there's a scale factor, which is in MX9 and MX7 calculated from the wheel radius input in the Trimble mobile imaging interface where you operate the system. But keep in mind, if you have a precise question how to do something with GUMS or DMI, there's always a manual available. If you don't find that, you can always contact us and ask for it. So keep that in mind. I have here an example of a MX7 roof rack. In this case, for example, the GUMS lever arms are measured from this reference pin here to the center of the antenna. So for example, X in this case could be something like 1.5 meters, 2 meters, depending on where the how long the roof bar is. I think it's something around 1.5 meters. The Y lever arm is probably close to 0, and Z lever arm would be minus roughly 5 centimeters, couple inches. So that's an example of the axis and the directions of the values. Same goes for the DMI. Why the GUMS lever arms should be precise? We always say that in the field you can measure those with couple centimeter accuracy, and for most applications that's fine. But if you use GUMS in the post-processing, I want to show something you might see if you don't have precise lever arms. And this example is especially with wrong Y lever arm used in the post-processing. So we have here on the left side, we have a correct lever arms, but on the right side, we have wrong Y lever arm, which gives us information so that actually the system would be clockwise rotated from the top view. So it's actually giving us wrong information if the Y lever arm is so different that it gets rotated like this. In this case, you might see this kind of effect in the data. So blue line here on the both side is a building wall. This is a top view, of course. So the blue line is where the building wall should be in the point cloud. So we are talking about dual head MX9. And the scanner, because we have two scanners, the left and right scanners might be separated like this. So because the solution of the trajectory is kind of rotated, the left scanner gets kind of narrower and the right scanner data gets kind of wider, and both of them are kind of tilted in the clockwise rotation. So if you see in the data phenomena like this kind of offset in the vertical walls, you might want to go back to postback and see if you used guns and see if you can refine your lever arm. And that actually brings us to the next topic, which is the lever arm calibration. So I want to here show how you can refine your lever arm in postback. So first of all, you need to go to a menu where the guns vector is given. Note that these values might be different from the ones you inputted to the TMI because we are adding some internal lever arms. Then you change the standard deviation to unknown. So we tell postback that we don't trust these values, calculate us better values, then we process. We can do just the forward processing. Then we go to the plots of postback and we try to find this plot under calibrated installation parameters, and we check the Y guns lever arm plot. It will usually kind of rotate around or change around in the beginning of the mission, and then it kind of converges to a good solution. And we want to take that part where it has converged and take the value from there. Then we take this value, we go to the same menu again, and we input that value for the Y lever arm and change the slider to 5 centimeters. So now we tell postback that we trust these values. We usually say that leave this to 5 centimeters instead of 1 centimeter, so not to put too much weight on the guns. Then we can just run all processing and we will have a likely better solution. We can do the same for X and Z lever arms as well. All right, we can do the same thing for DMI, not for the lever arms so reliably, but we can do it for the scale factor. Same, the concept is the same. So we set the standard deviation of a scale factor to 100%. We make sure that it's somewhere close to reality, so plus minus 15% of the actual value. Run all processing, and then we open the similar plot as with the guns, but this time DMI scale factor plot. And you can see the same effect here. It changes over the time. Again, we take the converged value from around there, input that value for the new scale factor, process again. Keep in mind that you can repeat this. You can kind of do iterations for this calibration if necessary until the changes are very small. So this is the way you could calibrate lever arms and scale factor if you don't trust the ones you got from the field. Or maybe it's just a good quality control check every now and then that if your lever arms look to be correct or not. All right, that's about guns and DMI. I hope that was helpful for some of you, at least. The next thing I want to talk about is postback, and I want to show some tips and tricks and some best practices we get asked for oftenly, many times. So I want to show you with hands-on some tips here. So I want to show you how you can visualize the data quality on the plan view of postback, and also where the runs are on the postback trajectory. And same thing for the plots. So I want to show where how you can see if data was collected in the plots. and how quickly show how to find some statistics from the plots. Additionally, I want to show you how you can export the trajectory in custom formats from PostBack, and I will show the KML option for Google Earth, especially here. So let me switch to PostBack. I have here a small mission we made here close to our office in Germany. First thing I want to do is I want to enable a view filter manager under the view manager. Open that menu. And I hide the real-time trajectory, so I want to just see the green post-processed solution, because that's what I will use in the next step. So I'm interested in the quality of that. Then I will click the trajectory tab here in the bottom, and I will color code by position RMS. The default values are not very useful for me, so I will actually colorize so that anything under 3 centimeters, I think that's a bit over an inch, are shown in green. Anything above between 3 and 6 centimeters is shown on yellow, and anything above up to 1 meter is shown on red. So as you can see on the right side on the plan view, now the trajectory has changed color based on the position RMS. So I can see that there are 3 locations where the quality of or the position RMS, the expected accuracy is over 6 centimeters. These areas are here, here, and here. And of course, my next question would be that if I collected actually some scans or images during these areas, because we don't always collect data when we drive around with the MX-9 or MX-7 or any system. So what I can do, I can go to View tab and enable Event 1 here. This will show in the map these orange triangles, and each orange triangle is an image trigger. So image was taken in this location. So based on that, I can now see that only of the locations I'm interested about is this one where I actually collect the data. So I don't really care what happened here because I don't have any images or scans from these areas. So I would only pay attention to this area here. Next, I want to show you how to do the same thing on the plots. So I can take the any of the plots. I will now take the down position error. So that's the elevation position error in RMS. Scale here is in meters, and this is the time from the beginning to the end of the trajectory. And I can see that there are two smaller spikes here where the accuracy is roughly 5 centimeters, and one higher spike where the RMS value is over 25 centimeters. So I would be now interested in the same thing if data was collected during this low accuracy spike here. So what I can do here is I can press View, Plot Markers, and show the Event 1 as well here. Here is the kind of a black square instead of the triangle, but same thing. So I'm now happy that no data was collected during this spike here. And this same thing goes for the other plots as well. One more thing I want to show here is the statistics. You can do that from View and press Statistics, and that will calculate your RMS, mean, minimum, and maximum values of the plot you have selected here. So that's a nice way to calculate some values for your data if you're interested in that, or maybe reporting reasons or something like that. All right, next thing I want to show is how to export the trajectory here to any third-party format. So for example, I would like to keep track of my missions in GIS software or Google Earth or whatever. You can always go to Tools, Export, and then you will have a folder where the export goes, and then you can just choose the format. By default, you will have ASCII, DXF, KML, shapefile, and so on. You can also do custom formats. custom ASCII format, so you can choose what data you want to input. In this case, I select the KML, for example. I can define what is the output rate. So I can export everything, or I can just export, for example, the event one time, so only the actual data collection locations, or specified time or distance interval. I will not export this now. I have done that already, so I will just show you how this data looks in the Google Earth. So keep in mind the shape of this trajectory here. It's the same trajectory here in Google Earth. So what I would use this for is, of course, I could just keep track of where I traveled, or I could check that if there's an environmental reason why the data here is maybe not so good as it's in this area. And if I look at here, and same area is around here in the map, I can see that the bad area was here on the forest, very thick forest road where we traveled. And immediately when we go to the open sky area between the fields, the solution also gets better. So that's a nice thing we can do. Final thing I want to talk about in Postback is the navdiff tool. It's found on the plots under tools, navdiff. And this tool is meant for comparing two trajectories from the same mission. So you can do two processings with maybe different settings, different base station or whatever, and compare the positional difference between these two solutions. So you just input the reference data from the other mission, the SBET file from the other mission. And I will go back to slides because I have the example here on the slides. So yeah, you can find it there. And on the right side, you see this plot. And what this plot actually is the difference between the same trajectory of MX9 with AP60 system processed in Postback version 8.5 and 8.6. So completely the same settings, same data, but we get slightly different positional values for the data. And this is related to the fact that I was talking about in the beginning, that Postback 8.6 is giving a slightly better performance for this data type of MX9 and AP60. So you can see that mostly the changes are sub-centimeter, but there are some locations where the new version we would expect it to give a couple centimeters different result, and likely that the solution is better with the 8.6. So this is only telling us the difference, not which one is better. All right. The final topic I want to cover is the base station and some best practices for base station data. So base station it's sometimes a little bit, I would say, overlooked because it's just the data you get from somewhere and you just need it to process your data. But actually, it's very important to have good base station data, properly defined and so on. So I divided this to 6 parts, and I want to answer to the question that what you need to consider when you're preparing a base station for your mission. First thing is the access to base stations. So I want to talk a little bit about where you can get base station data. I want to also talk about the location where your base station should be and the amount of base stations. So sometimes one base station is not enough. Also the accuracy and the definition of the base station, frequency of the data correction we get from the base station, logged satellite constellations. So this is related to the Galileo Beidou systems which are now available. And finally, the data format of the base station data. Okay, let's go step by step. The first thing is the access. So where can I get base station data? First option is using the Applanix Smart Base database. This is the tool you can access through the Find Base Station in Postback. I would personally say that this is not my first option because the base stations in this database are sometimes quite limited on geographical availability. So it might be that you don't have a base station close enough. Also, some of the base stations in this database are not giving us dense enough frequency of data. Second option I would say is the Trimble VRS network. This network, if it's available, it's very usually dense and accurate. So it's a reliable data, but it's only available in certain countries or certain states in USA. Of course, usually there's a local provider. So it could be that someone is using Trimble technology, but it's not owned by Trimble. And it's really dependent on the country or region if this is available and how good data you get from the local provider. The last option would be do-it-yourself base station. So that's, in simple way said, you set up your own GNS receiver on a known point. But the thing you have to consider here is that you need to have the equipment to do this, and you need to have the know-how to do this, how to set up the GNS receiver in correct mode and so on. If we think about the Trimble VRS network, I can show a couple images. So on the top is Europe. So the places in orange are covered by Trimble-owned network. Also, there are some countries where there is a Trimble network based on Trimble technology, but it's not owned by Trimble. And in the bottom, it's the same image for Canada and USA. So there are some states which are nicely covered in USA and also some regions in Canada, but not everywhere. Okay, next topic, where my base station should be and how many base stations do I need for my mission. First of all, very important rule of thumb is that your base station should be maximum of 20 to 30 kilometers away from your trajectory. Anything above that will introduce more errors to your data. If there is no base station available close by, you can consider the option to build a so-called smart base network. I will not show how to do this here. I don't have time, but keep in mind there's an option like this. If you have questions, you can always contact us about that. Or if you have kind of a long corridor type of project, you might need multiple base stations along the trajectory, along the corridor. I have a couple images here to show you the same things in visual way. This could be an example of the pink trajectory, which is within 30 kilometer radius of this base station in the middle. So that would be a good way to have a base station. Or if you have on the right side now a long corridor, maybe extending over 100 kilometers, then you would probably need 2 or 3 base stations like this, which are in total covering your trajectory. And that's what we call multi-single base mode in POSPEC. All right. Next thing is that what is the effect of base station coordinate, frame, and epoch? So if you think of the base station data, it's always set on a coordinate. And this coordinate should be as precise as possible. If there is a 1 inch mismatch in the base station coordinate, that systematic error will be also applied to the trajectory data. So it's a possible error source if it's not well known. Also, you should pay some attention to the logging frame and epoch of the base station so that it can be properly configured in POSPEC if needed. If you're unsure about your coordinate, you can use function you will find by right-clicking the base station data in POSPEC. It's called compute RTX coordinate, and that will send the data to this RTX service and returns you a precise coordinate and frame and epoch. you need to have just long enough data for this. So I think it's reliable computation after some 1 hour of data collection. And if you want to check the coordinate of your base station, you can right click and select coordinate manager, and you can see a window like this in PostPack. Right, next thing, at what interval should my base station give corrections? If we think of the mobile mapping systems of Trimble, at least, they are logging navigation data with very high frequency. For example, the IMU is logging at 200 Hertz, so 200 times per second. And the GNSS is getting 1 point every second. And in PostPack, we are correcting this data with the base station. So therefore, the base station should also give corrections at 1 Hertz. So for example, if we get correction with only 15-second interval, anything between those 15 seconds is not corrected properly. Yeah, so you will get some errors to the data if you use anything less than 1 Hertz. Also keep in mind that the base station data should cover time-wise the whole mission from the start to the end. If you are familiar with the Trimble reference data shop, there's this menu where when you order the data about the interval, by default, that's usually at 15 seconds. So you have to always remember to change that to 1 second data. Next thing, does it matter which GNSS satellite constellations my base station logs? Yes, it does. So logging all available GNSS constellations will benefit the processing. So we will have more and more satellites available in the sky. Now we have GPS, GLONASS, Galileo, Beidou. And we have been able to use all the constellations since PostPack 8.4, which was released, I think, in 2019. And since PostLVE firmware 9.13, roughly from the same time. So if your base station is logging Galileo and Beidou, we can use those in PostPack as well. I have here an example of amount of visible satellites with and without PostPack, without Galileo and Beidou. On the left side, you see the number of satellites in the baseline. With Galileo and Beidou, we get up to 28 satellites, and the mean value is 16. And without, we get maximum of roughly 18 satellites, and the mean value is 11. So there's quite a significant difference in the amount of satellites here. The final thing about base station is the data format. Does it matter which data format you use? In general, PostPack supports all the typical GNSS data formats like RINEX, DAT, TO2 from Trimble. Personally, I would recommend using RINEX and the newest versions of RINEX or TO2 so that you can use Galileo and Beidou in PostPack. Because, for example, old RINEX versions do not support Galileo and Beidou data. In the Trimble reference data shop, you can choose the options here, and personally, I usually take the TO2 file. All right, that's the end of the content. I will just quickly show a couple ways to find information from online resources. First of all, we released some months ago a mobile mapping specific knowledge base. It's available at help.trimblesgeospatial.com/mobile mapping KB. So knowledge base. And in this site, you can find the most common solutions for issues with data and different products. So you can search by a keyword or you can search by a product. There's also some FAQ documents here as well. So that's a good and maybe the first place where you should go for some information about the issue or question you are facing before contacting us. We might be faster with this one. Also keep in mind the Trimble mobile mapping YouTube channel. We will usually upload pretty much everything every video material we have, webinars, tutorials, marketing videos, whatever. So if you just go to YouTube and search for Trimble mobile mapping, you will find that channel. We already have something like close to 500 subscribers, so that's nice. Maybe you already are subscribing. The final place is the Trimble Geospatial Webinar Center. So it's archive of all Trimble Geospatial webinars ever done. I don't know ever, but from recent years. And for example, all the mobile mapping webinars are found here, and we have already dozens of those available. So it's found on geospatial.trimble.com/webinars. Finally, a reminder from the support team. So you can always reach us through imaging_support@trimble.com. Please always use this email to contact us instead of our personal emails, because this will help us to document and track the cases for supporting you better. We are able to switch the cases between different guys in the support to, for example, cover holidays or time zones or whatever. Also, small tip here, you might want to use the product name you want to ask about in the subject of your email. So for example, I'm having a problem with MX9 or I have a question about postback, and this will find the correct email box faster. All right, I think that's it from my side, and now it's time to check the questions. Bishoy, are you awake? Do we have any?
Yeah, I'm still there. So yes, we have received a couple of questions during the presentation, and it's also time now for anyone, please, if you have any questions, send us your questions, and we will be happy to answer them right now. So the first question we received was about the MX2. So what options the users of MX2 systems have in terms of processing data besides Trimble Trident? My understanding is that TBC is not compatible with MX2 data. Yes, that is correct. So for MX2 data, Trident is a must. So you will need to process your data first in Trident and do any operations you would like on the data preparation inside Trident. So this could be registration, could be colorization, could be any point cloud cleaning or removal of ghosts or so. Can do all of that inside Trident, and there is no way around it. But you have then the option to continue either in Trident with data extraction, or you can go to another software like Tmx and do the data extraction or the feature extraction there. So Trident is first a must. This is the first stepping stone, and then you can either continue in Trident or you can go to Tmx. So I hope this answers the question. Next question, is it possible to, actually a series of questions that are all related to the same topic. So is it possible to emulate the R12 performance under trees? For example, for AP20 MX2 Regal VMZ? No, unfortunately not. So the processing engine behind the data that comes from mobile mapping systems is different from the processing engine in TBC. So you process your trajectory in postback, and this is different than processing your raw data that comes or GNSS measurements that comes from the R12 in TBC. So the engines are different and the behaviors are different, and it's at the end of the day, the R12 utilizes multiple sensors like the tilt sensor and so to reach good solution in difficult conditions. But with the mobile mapping data, it's dynamic, it's moving. So we use the car movement and all of that to reach a solution, and the situation is completely different here.
Yeah, maybe I can add something. There's a related question if we have any tips for processing trajectory which is collected under the trees. I would say that something you can do is in postback you can consider the setting bound under algorithms for GNS inertial processor, there's the multipath setting, and usually what trees do for the GNS data is that they introduce more multipath, and you could set this setting to high if you know that there's a lot of multipath coming from trees or buildings, and that will change the weighting of the GNS and IMU measurements a bit, and it does some kind of filtering for the data. So that's maybe something you could do actually in such cases.
Yeah.
All right.
All right. So another question we have here: what is the future of MX2? So it's actually difficult to answer this question because I'm not at liberty to actually answer this type of questions regarding product life cycle or product future. So I'm sorry, I don't have any answers to this question now. All what we know is that we have the MX2 still available, some of them still available, but maybe not for a long time. So this is the only thing I could say. Is it possible to remove the image optimization for the planar images in TBC? It may be good to do to make measurements on the images, but may also want to remove if the planar images are at level. Yes, absolutely. So in the TBC options, under the mobile mapping category, you can uncheck the image optimization option. So Yoni, can you please bring up the screenshot here?
Just a moment. Oops. Something happened.
Yeah.
Yeah, there it is. So yeah.
So yeah, if you go in the options, you can check or uncheck this box to enable the automatic enhancement. And also, by the way, the automatic enhancement, of course, reflects on your deliverables. So if it's on, then your images, exported images, will benefit from that. And if it's off, then you get the original images. Right. Another question, does DMX9 work in tunnels even if there is no GNSS signal for a long time? So if you say just work, yes, it does work. So it definitely works, but of course the specifications of the AP60 or AP40 apply here. So under a certain outage, whether it's 1 minute or 1 kilometer, whichever is reached first, then if you're doing the AP60, you should have no effect on the data, and if you're using the AP40, your data should be affected very slightly, maybe an additional centimeter in X, Y, and maybe 2 centimeters in Z or so. But in general, for longer durations, from some experience that we've had in longer projects, tunnels up to 6 or 7 kilometers, there were no problems during post-back processing, meaning the trajectory, for example, was completely processable in post-back, even though that the error started increasing, but we never had any problems like what we would have, for example, with an MX7, where immediately the trajectory would simply stop processing, and therefore we need to cut it maybe in parts. So that was not the case. And the data quality in general was quite good. It's just a matter of how your tunnel looks like. So twisted tunnel or straight tunnel or so, then of course there will be degradation in the data quality according to how big the tunnel is. But, and of course there's always but, this can be corrected and fixed with control points. So control points can help you greatly in tunnels. And you can also mix that with position fixes.
All right, no more questions so far. And of course, if you have a long question you don't have time to write here, you can send us email as well. Feel free to do so.
Yep, so I think no more questions are coming. Going once, going twice. All right, so I think on this note, we can end our webinar, and we would like to thank you very much for joining us today. And we really hope to see you again. And please contact us on imaging support if you have any questions, or if you have any ideas for next webinars, we will be happy to implement those. So thank you, stay safe, stay healthy, and we'll talk to you later.
Thank you guys, bye-bye.